Um, like here, it actually looks like I think it's diffusing, like, and kind of combining with the molecules of the water. So if you add it in, maybe the molecules will be already more expanded. So it's possible it could take longer to pass through the cell membrane. I'm not sure.
You want to add to that?
I just want to say that when the water with the food coloring was dissolving, it kind of looked like it was performing osmosis, like going through the cell membranes of the water, and kind of like adding on to what John said, kind of like looking for open space to spread.
So are we saying that water has a cell membrane?
I think it does, because why would if there was no cell membranes, why would the molecules be splitting up separately? Is what I'm thinking right now.
I'm not really sure because it's a liquid and it has no it doesn't have any solid. It's not solid, so I think it would. I don't think there are cells in water, so I think that the food coloring is combining with the existing molecules.
I'm pretty sure that there are molecules in water, because I remember cells in water, because cells. I remember there being molecules in water, but I'm not sure about cells, because I remember talking about how molecules in solids are more closer together, in liquids like a little bit more separated, and then in gas like totally separated. But cells, I'm not sure about cells, but it's possible.
From that video we watched, like, back there, it said, I get what you're saying about the molecules being more separated, because if they're separated, then the molecules of the food coloring have more places to go, and then they can spread out and kind of combine to make a thicker liquid.
So if you go back to just the initial question about the process of the temperature and its effect on osmosis, how would you describe that for future? And is there anything that you would like to continue this study with in the future by exploring?
I would like to figure out if there's any cell membranes in water, or if there's none, or if there is a cell in water, because I'm not sure there is one in water.
I think that I'd also like to know more about, like, if there are cells in water, and I think it would be interesting to know, like, what would happen if we added like the food coloring, or if we added different liquids to the sodium polyacrylate, and see if it made the process quicken or change in any way.
No, just what was the reaction with temperature? How did temperature affect viscosity?
As I said before, it kind of seems to be that like like the warmer the temperature is of the water, the faster the process of osmosis takes place, and like its effect on the cell membrane. And I'd also like to learn more. Like, here we're using sodium polyacrylate, but I wanted to know if it could be other substances that like osmosis takes place on, like for instance, like Kool-Aid or like Crystal Light. It's like a powdery substance, and when you put water in it, it kind of like, it didn't turn like gel, but it kind of did turn into something different, like the food coloring did. So maybe it could be like the same process.
So it sounds like you're talking more about the mixtures versus a compound and the difference between the viscosity and if it's actually absorption that's taking place, and also this whole idea of the cell membranes, because you know that the process of osmosis takes place by having water absorbed by going through some sort of membrane, some sort of outside layer. So kind of looking at that a little bit more. And I think what the membrane that we're kind of focusing on is the membrane of the sodium polyacrylate, the actual substance that's doing the absorption. So, and you came up with some really great ideas for next study. So what I'd like you to do is, while you're writing in your conclusions and coming up with conclusions, try to put together one of those experiments, and maybe we can actually look at one of those experiments and design another one like we did design this one for the future. So you can add that to your conclusions. All right? Thank you. All right. So you just had an opportunity to participate in this same kind of activity with analyzing temperature and its impact on viscosity and the absorption of the sodium polyacrylate. So what are some of your findings and some of your thoughts that you found after this analysis?
I think that the viscosity decreased much more quickly than before with, I think it was room temperature water, like the experiments that we did previously. I think it's because the warm water molecules gave the molecules of the gel created by the sodium polyacrylate more space to move, which made it decrease in viscosity faster.
I agree with Aya, because our hypothesis was that it would decrease much faster than room temperature, because we said the hot water would enter the sodium polyacrylate membrane, so it could decrease much faster instead of room temperature, because it took us like one. It took us like 190 to look like full liquid, in our other in room temperature.
What's the unit of measurement you're using?
A unit much of water.
Yeah, what were you measuring water in?
It was in about we used 30 in each. First we started with 100, and then from there we used 30.
100 what?
100 millimeters of water, and from
Liters, right?
Yeah, milliliters.
Milliliters are for measuring the length of something. Milliliters is for measuring liquid volume. Okay.
Yeah.
Continue your thought.
Yeah, we first started with 100 milliliters, and then from there we took on to 130 milliliters, and then so on. So I think it decreased much faster with hot temperature water.
The molecules moved faster because, well, the liquid, the viscosity decreased faster because the molecules were moving faster, and that allowed the liquid to become thinner and move faster. So that's it proved that our hypothesis was correct, because we said that we predicted that it would make the fluid more liquidy, and it would make it more liquidy and
Please
less
return court key number 4 to the main office. I have court
Visca-
key number 3
um
that could go
and
with
have
the
less
shelter.
viscosity.
Okay. So it sounds like you keep saying this liquidy part where you're using that word to describe the way the sodium polyacrylate worked with the hotter temperature water. So what is it that you're actually trying to describe in terms of, what happened when the hot water was poured in? What was the reaction that took place?
The reaction that took place was that the sodium polyacrylate automatically turned into a gel, but less dense as with room temperature water. So with the next couple of doses of water, it quickly turned into liquid and was able to move faster. And I agree with you, Jonah, and based on this experiment, I think that if we used cold water instead of hot, because then the viscosity would increase when you first added water, because like when you think of an ice cube, it's much more dense than like warm water. So maybe if you used cold water instead of room temperature or warm, then the gel would become thicker with less and decrease in viscosity less quickly.
I agree with both of you, because if we did use cold water, then it would take a lot more time, or like it would have never got to a liquid. And with room temperature, it took us like 90 millimeters of water to get it to the first 100 millimeters of water what we did with the sodium polyacrylate, because in the first 100 it already turned into a less liquidy form of water, and with the 30 millimeters of water when we used with room temperature, it would at least be a little bit more solid than we did with the 100 millimeters of water.
Okay, so if you were to further this experiment and you wanted to take it one step further from that, it sounds like what you would do is you would use different temperatures of the water, because we've tested room temperature water, we've tested hot water, but we haven't really tested really cold water. And that sounds like because of an ice cube being more viscous and making liquid more viscous, it would potentially make it slower absorption rate based on what you're noticing from what happened with the hot water. So, the temperature of the water was much higher than we had worked with, and I think it's important to be able to keep in mind that the hotter the water, and it goes back to what you guys said, the hotter the water, the more quickly that the molecules pull apart in the sodium polyacrylate to be able to absorb the liquid, so that it creates like an equal balance. And then as more and more water gets poured in, the sodium polyacrylate amount is no longer able to keep up, and it turns into that, what you guys say, the liquidy portion, and it now becomes no longer able to do its job and no longer able to absorb and loses viscosity. All right, you want to add to that?
Since the viscosity of the gel, I guess, that's created by water, I was wondering, how would it do the same thing with like different liquids, like with like lemonade or iced tea? Like, would it change in viscosity, or would it not react at all?
Those are good points. And we can look at those. Those are something we can look at later on. Good job, dudes.
Cut.